We good? We good? Okay, we're good. Good evening, everybody. Welcome to our meeting, and I'm going to move things right along. I'm going to jump right into this because, again, we find ourselves with more than the recommended number of slides, so speakers be warned. I didn't bring the hook, but I can fake it, so I'm going to try to keep you in line there, and hopefully we won't run over. We've got a really cool program tonight for a couple of different reasons. Actually, we can throw on the next slide there. We can have it. Oh, or I can do that. Yes, I have the power.
You have the power.
No, I don't. He's got the power. No, he doesn't.
Actually, I don't even have the power.
What's that? What's going on there? There we go. Okay, I may have to rely on you. Okay, I'm not going to tell you about Tony's little blurb there because I want him to tell you about that. We've got Al Scott with our astronomy news update. Tim is finally going to get a chance to talk about his misadventures in Hawaii. Brian McCullough, who is finally going to show us his moon sketching video. Remember that little exercise we did back in May? We now have the video. We have the technology. And he's also going to talk about his trip to the Mount Megantic Observatory. We'll have our break then. We've got a pile of really cool observations. Stephen will give us a bit of an update on public outreach. And then we've got Alan Ward, who's going to present a really interesting talk about what's Apatosaurus max. He presented this talk at Starfest this year. And for those of you that love your telescopes, now you're going to see how they work. So looking forward to that.
See if that hasn't been turned off.
Oh, yeah? Is there an off button there?
Yeah,
Okay. Good. We are
Amazing
good.
how much better it works when it's turned
When
on.
it's turned on, yeah. So, what can I say? I hope you enjoyed our little panorama there at the beginnings there. I stitched two of them together. Those panoramas, one of them obviously was in tribute to the passing of Neil Armstrong, certainly an iconic figure of our time. The very public face of the man that took mankind on that giant leap. So sorry to see Neil go. I was hoping that the three of them could get together on the 50th anniversary for a special bash they have planned, but such is not to be. So we wish Neil well on his next phase of his journey into the cosmos there. In recognition of that, we also we have something special for you tonight. So I'm not gonna let the cat out of the bag. I'm gonna let Tony handle this one. So Tony, if you want to come and tell us what you've got there.
It's not that special.
Oh, yes, it is. Absolutely.
Well,
it
it's
is.
something different anyway.
It's very different, and no, it's definitely special.
Got it. Okay. When Apollo 11 returned from the moon, of course, it had a very precious cargo of rocks and other surface material aboard, and you can bet that that material was studied extremely closely in the lab back on Earth. And the people that studied it found a new mineral, one that had not been identified before in any other material. It's a magnesium iron titanium oxide, and in honor of the men that brought it back, they called it armalcolite for Armstrong, Aldrin, and Collins. This is its entry on mindat.org, which is an online mineralogical database. I would encourage you, if you're at least bit interested in minerals, to go and see this sometime. After it was discovered subsequently, it was identified finally in some rocks on Earth, but it's a very rare mineral. It tends to occur in rocks of extreme composition, mostly extruded on the surface as a very high temperature lavas. It's a low pressure, high temperature mineral that you only see in very rich, very titanium rich rocks. Mostly it occurs in rocks called lamproites, as you can see. If I got a pointer here, does this work? Yeah, there we go. And kimberlites, which of course are diamond-bearing rocks, and I guess it's found in impact melts sometimes, and it's also been found, I guess, in meteorites since then. Now, this, of course, is not the type locality of armalcolite, as some might have you believe. This is. This is the Apollo 11 site. This image was released, as you can see, in March of this year. In addition to the LEM, of course, whoops. Let's go back there. There we go.
One button, Igor.
Yeah, just one. Okay, and the right one. some of the scientific packages left. You can also see the trail of footprints. This is actually Armstrong walking off to the West Crater. I think we might have had this picture up earlier this year. I'm not sure if...
We did.
I think we did, yeah, okay. Now, no self-respecting geologist would have selected this as a campsite because there's no outcrop there. Of course, they want an easy place to land. It's just a lot of impact ejecta, a few loose rocks, and a lot of dust and gravel and stuff like that. So I don't think they brought back too many rocks. I haven't really had a chance to see the original literature on armalcolite. It's in special NASA volumes, which I can't get in my online library at work. But obviously they collected a lot of stuff scraped from the surface, and there's Aldrin sampling some core. Now, in my job as a geologist, I actually study lamproites amongst other rocks, and so I had an opportunity to go to a place called Smoky Butte, Montana, and collect some of the most armalcolite-rich rocks that we have around here. And as a door prize, I have a piece of it with armalcolite and this disc as well, which has a few other images and some information. I know that there's at least one other person that regularly attends here that's also interested in minerals as well as astronomy as well as me. And perhaps one of you has a son or a daughter at home that has interest in that way as well. So this is a photograph, a close-up photograph actually of the rock that I have here. And the armalcolite is very, very tiny. It's these metallic black elongated grains that you see here. So 1/10 of a millimeter is quite large for an armalcolite crystal. And the sample is quite small, but I guarantee to you it contains thousands of these. And that is a backscattered electron image of a scanning electron microscope. This is armalcolite here, the white. This is another mineral called apatite, and these gray laths, dark gray laths that you see here are sanidine. And I think that's about all I wanted to say. So good luck to someone to pick this up.
Well, thank you very much. That's very generous. So be sure at the break to come up, if you haven't already, come up and get your ticket, because you can't play unless you have one of those. Okay, moving right along. Actually, I lost my train of thought on the original panorama. I wanted to point this out to you. This is a link that Brian sent to me just a few days ago, and it's very, very cool. I captured those two panoramas, one of Apollo 11, one of the Curiosity site, and the site is called panoramas.dk. Check it out. This is a tool that this company, I think, sells. And what they've done is they've taken NASA imagery and they basically stitch it into a panorama. Now, the captures that I did there were crude in comparison. If you go up on the site, the images will be a lot cleaner, and you can stop the motion, or you can set it in motion. You can zoom in on any part of the parameter, really high detail there. So and they've got prepared panoramas on all the Apollo missions, on the Curiosity piece there, which I showed you there. So well worth checking out. Thanks again for sending that to me, Brian. That's a pretty cool little application there.
Just one thing about Neil Armstrong is his funeral.
Yes?
Was on the blue moon.
Oh, was it?
Yeah.
Oh, geez. How appropriate. Yeah. Good. Thank you. So, yeah, panoramas.dk. Check it out. I think you might find that interesting. Ottawa members in the news. We've got a couple of really interesting entries here. Next one, please. In the current issue of Sky News. Whoop.
I thought we had Rolf highlighted there. Sorry about that.
I thought we did too, actually. But that's okay. Is Rolf with us today? Is he? Okay, Rolf, hold back that enthusiasm. Excellent. That's a beautiful shot, Rolf. That's amazing. And certainly Terence Dickinson has no arguments with that as well. That's just fantastically detailed. Nice piece of work. Next one. And again, Rolf's been a busy lad, eh? Rolf's image up at the top right-hand corner there. Beautiful, nice, very crisp shot of the transit of Venus. So again, congratulations, Rolf. Nice work. All right, after that one. Now here's an interesting one. Again, in the current issue of Sky News by our own Glenn Ledrew, a rather informative article, well worth the read on runaway stars. So I think you will find that very an interesting read, because it'll give you a feel for some of the dynamics of objects in our sort of neck of the galaxy, and how some of them are rather strange in their motion there. So again, nice job, Glenn, there, and nice illustration as well. And next, please. Astronomy sketch of the day site. I don't know if how many of you saw this. This is a really nice compilation that people put together in honor of Neil Armstrong, and to that end, they used his portrait there and surrounded him by some very impressive lunar sketches done by the contributors to that site. And I draw your attention to this particular work down here, because if you flip to the next one, that's from our own Gordon Webster. So again, nice work, Gordon. That's beautiful. Well done. Nice with the moon and M44, the beehive there. Excellent. So nice work all around, guys. Super. Next one, please. Oh, is that it? Oh, that's it. Okay. Thanks again for that. And without further ado, Al Scott. I'm kind of trying to boogie along here, because I know that a couple of our talks are on the long side there. All yours, Al.
Good evening. So a couple interesting little news tidbits for you this month. First one is on a super bubble in LMC. LMC is the Large Magellanic Cloud, a small satellite galaxy of the Milky Way, about 160,000 light years from Earth. And you can see it from the southern hemisphere. In this photograph, which is a composite from different observatories in multiple wavelengths, many new stars, some of them quite massive, are forming in the star cluster called NGC 1929, which is embedded in the nebula N44. Now, what we're seeing here is a composite. The blue is actually X-ray observations from the Chandra telescope. The yellow is visible light, and the red is infrared emission from dust. So I see optical is the ESO 2.2 meter. So what we would see is just the yellow band, but by putting all these things together, you actually get a good understanding of the energetics of this, what's called a super bubble. Now, massive stars produce intense radiation and expel matter at high speeds and race through their evolution to explode as supernovae. The winds in supernovae shock waves carve out huge cavities called superbubbles from the surrounding gas of the interstellar medium. X-rays show hot regions created by these winds and shocks, while infrared data carve out the dust, show where the dust and cooler gas are found. The optical light from the 2.2 meter European Southern Observatory's telescope in Chile shows where ultraviolet radiation from hot young stars is causing gas in the nebula to glow. And that's what you would normally see if you trained your telescope on it, is just the yellow areas. A long-running problem in high-energy astrophysics has been that some superbubbles in the LMC, including N44, give off a lot more X-rays than expected from mathematical models of their structure. The models assume that hot X-ray emitting gas has been produced by winds from massive stars and the remains of several supernovae. But recent studies have shown that there are two extra sources of X-ray emission in this bubble that haven't been included in the models. And these are the shock waves from the supernova striking the walls of the cavity, and they're creating extra X-rays, and then the hot material is evaporating from these cavity walls and emitting X-rays as well. So it's really nice just because it's a really cool picture, and it gives you a very good feel for three-dimensionally what's going on here. That the supernovas are blowing a bubble in the interstellar medium filled with X-rays. My second item is got to do with Kepler, Shades of Tatooine. NASA's Kepler mission, which is observing several about 100,000 stars towards the center of the galaxy, is looking for dips in their brightness when they become occulted by planets. NASA's Kepler mission has discovered multiple transiting planets orbiting twin suns for the first time. The system, known as a circumbinary planetary system, is 4,900 light years from Earth in the constellation of Cygnus. Astronomers detected two planets in the system. The system is a pair of stars that eclipse each other every 7.5 days. So Mathematically, people didn't think that you could have planets about binary stars until recently, but now they've found some stable orbits. If the stars are orbiting close enough together, the planets then orbit their barycenters and don't get too perturbed by the two stars. So it seems to be somewhat stable situation. One of the stars is similar to the Sun in size, but only 84% is bright. The second is really small, but 1/3 the size of the Sun, and less than 1% is bright. The inner planet, Kepler-47b, orbits the pair of stars in less than 50 days. It can't be directly viewed, but is thought to be a sweltering world where destruction of methane in its superheated atmosphere might lead to a thick haze that could blanket the planet. At 3 times the radius of Earth, Kepler-47b is the smallest known transiting circumbinary planet. The outer planet, however, Kepler-47c, orbits every 303 days, placing it in the habitable zone of this star system, where liquid water might exist on the surface of a rocky planet. However, Kepler-47c is thought to be a gas giant, slightly larger than Neptune, where you might have an atmosphere with thick water vapor clouds, for example. And if this planet had moons, they would be very interesting targets for astrobiological investigators. So just some interesting tidbits to leave you with. Thank you.
Thank you. All right. Moving right along, Gary is a little bit swamped this month there, and so I just put together something very, very simple for Ottawa skies. Didn't really cite out anything in particular, other than I draw your attention to the moon phases. You can see when when the various phases occur. The reason I draw this out is September to me is September and October really are my favorite months of the year to do observing. The nights are getting longer. There's no bugs. The temperatures are reasonable. It won't be too much longer before we're down into the cold stuff there. So I try to get out as much as I can. So in September and October. So I just want to highlight that the moonless window is essentially opening now, and so for the next 2 weeks is prime time. The other nice part of this time of the year is that once the moon goes down, once twilight has ended, you've got 7 or 8 hours of true night, and in the course of that time, you can still examine the Milky Way and all the rich nebulosities there, or you can swing your attention over to Pegasus and check out galaxies there. So you've got a wide range of targets, you've got comfortable conditions and no bugs. So Ottawa skies this month, just get out and enjoy it, okay? And just to mention that, of course, fall begins on September the 22nd this year. So the nights are gonna get longer than the days, which is, for an astronomer, is a good thing. So that's basically all I have for that. And Tim, I'll let you handle this one.
Yeah, why not?
I'll let you do this one.
Yes, well, that's because I'm not going to trip over the cables. I'll trip over other things, but not the cables. Yeah, the brand new fangled astronomy brochure is out. Not a lot has changed other than you'll notice that now we're flogging specific solar observing days. And Earth Hour is now in the mix. We have the standard youth astronomy stuff, and the Astronomy for Everyone is the new rebranding of Astronomy Cafe, which has actually been it's been used a few times. Our biggest customer for that has actually been a singles group called Meat Market Adventures. And I'm not kidding. That's actually what they call themselves. Oh, I met my wife at Meat Market. Oh, yoy. Anyway. But they pay, so, you know.
I'm glad I let you handle that side.
No kidding. And the family astronomy workshops, of course, always good. Those always do really well with your little mini astronomers. So anyway. So there should be some brochures sitting out by the information desk, he said confidently. I haven't checked, but there should be. And then there's the stargazing evenings. So for anybody who's interested in private observing, you may look at these dates and know whenever there will be a cloudy evening. So this is a public service from the museum. You now know exactly when there will be a cloudy evening. The day after is usually clear. So, this is always very handy. This is far more accurate than the clear sky chart. Anyway, so that's, I don't think I can think of anything else to babble about. So, anyway, give it a thought. Did we have anything else? Another slide on this? It's me again. Yes. Actually, the story for this starts almost exactly 1 year ago when I was, I'm not sure how much of this I want to go into because, anyway, never mind.
I'll get the hook out.
Yeah, you'll get the hook out. Anyway, I happened to be looking through a Sky and Telescope magazine and noticed a little ad for observing the Venus transit from Hawaii and happened to notice and said, gee, that'd be kind of too bad. That'd be kind of fun. And whereupon my wife looked at it and said, Tim, you have to go. God, I'm a lucky guy. God love her. Anyway, so I did. And now this is kind of interesting because I found this an interesting adventure because I haven't been on an airplane since 1989. And it's gotten nastier to travel since then. If nothing else, they make you take your suspenders off. And I was thinking I was going to give everybody a floor show. Yes, walk through the scanner with your hands up. Not a chance, pal. Anyway. Yeah, quite. I mean, I have no modesty, but I also don't want to be arrested for indecency, particularly down south. Anyway, so what we have here is a little photograph of Venus right after second contact, and a palm tree out from my hotel window. So there you go on the morning of the transit. 15 hours of trip. I ended up in Honolulu. And that turned out to be a very good thing because I was absolutely fried when I got there. That's when I also discovered that cars have changed in many years, and they're all electric. My car keys actually have little metal things. It's a little metal thing with ridges on it, and there's no little thing to go click. So I had to go back to the car rental agency and say, excuse me, how do I open the trunk? And this woman sort of looks at me and says, you use the blue button, honey. Oh, crap, I'll go hide somewhere later. Anyway, over here you can see me looking pensively into the sky from my Waikiki hotel. And no, I did not bother going to Waikiki Beach because I hate beaches. Brian McCullough was insisting I had to go dabble my toes in the beach. And I said, no chance, I'm not going to let anything get a chance to eat my toes. But anyway, it was actually kind of a cool little place. And, of course, one has to have a cheeseburger in paradise, because that's the name of the place, the Waikiki Cheeseburger in Paradise, and yeah, it did get sued by Jimmy Buffett. I made a point of pointing out to my wife that there was nobody else in the hotel room. What I had was one of these really marvelous little gadgets that lets you take pictures of yourself. So, yeah, this one, searching for smile. Oh, we'll fire you! It's blinking. There. Searching for smile. So I made sure I demonstrated this when I got back home. It looks like I'm looking longingly into the dark. In fact, I'm thinking, when the hell does that damn coffee shop open? Anyway. It's cool because, you read about this stuff and you know it's going to be there. Down in the tropics, it's an instant sunset and an instant sunrise. But, man, to see it is another thing. You're just driving and then all of a sudden somebody turned the dark on. It's really bizarre. And then the same thing in the morning. You're sitting down there waiting for that damn coffee shop to open, and it's outside. Everything out down there is outside, including the outside. Anyway, never mind. So anyway, nice little view from over the city. And it's kind of a cool place. I'm not really into cities, but it's a cool place. Since I was down there, I happen to be a military history nut, and particularly in the Pacific theater of World War II, and specifically submarines. So a trip out to Pearl Harbor was an interesting sideline. And if you ever get a chance to visit there, the Pearl Harbor museums are really cool and incredibly cheap. $10 to wander around through there. I spent 2 hours poking around through holes, taking pictures of gauges and all that good stuff, and discovered that I was not alone. Too many crowds. I didn't bother going over to the other bits of the island. I had enough of being crowded. So, nice little interlude before heading off to the Big Island. And when you arrive there, there's a view of your view right when you get off the plane. It's a view only Tony or Simon could like. Because That's what it is. It's black 100-year-old lava. And the tower is basically sticking out of black 100-year-old lava. It looks like something out of a moon landing. Driving from the airport, and that's what you're driving through. Black lava with little bits of grass, and the cutest graffiti in creation. They do the graffiti with little bits of white coral, and there's not a nasty word there. It's all beautiful, nice stuff, you know, Tom loves Julie, and the weirdest one was I Heart Hockey, which in Hawaii seemed very odd, but at any rate. And then you've got in the background some hills. It's a cool place out there. It's all made out of 5 volcanoes, 2 of which are active. So it's an intriguing place. Transit day -1. We got our little briefing on what stuff was set up by Sky and Telescope and such like, and the weather forecast for the next day. And yeah, I made a point of telling my wife I got that picture with this too. So yeah.
Really believe that, eh?
Actually, she did, but that's usually because she knows that she's the only one with bad enough taste in men to marry me. But at any rate, yeah, I digress. The day before, we were all getting a little bit disappointed because the forecast for the next day absolutely stank. In fact, there was a forecast of a snowstorm on Mauna Kea. And if not a snowstorm, freezing rain on Mauna Kea. Fortunately, the storm went north of the island, but we had a whole lot of people there outside front checking out equipment, not looking at the sky. Yeah. But fortunately, every time we saw a patch of blue, we studiously ignored it and therefore made the sun come back. And then finally, it's the next day. Mauna Kea, we did the first bits of the observation from the Visitor Information Station. That's at 2,400 meters. And the place is an absolute zoo. In fact, the rangers had closed the access road to the mountain. If you didn't belong there by virtue of working there or had already booked a spot to come in, you couldn't get up there. The only exception they made was every car that left, another car could come up. And nobody left. So, but they did set up other satellite observing areas all over the island. So it did kind of work out. Right up there is actually the local quarters for astronomers and summit workers, where you'll stay up here and acclimatize. This is only part of the crowd. It got busier and busier and busier as the day wore on, and it's an interesting crew. Yeah, big geeky grin. We finished we finished the ingress. I watched second contact and first contact under absolutely spectacularly beautiful conditions. The best seeing I have ever seen in my life. Even with 50-mile-an-hour winds, it was still fantastic seeing. And of course, after that bit, then you can walk around and take a look. Now, I did all retinal imaging down there. I looked at it. Yeah, never mind, bad joke, forget it. But I just took a couple of keepsake pictures. After that, they shuttled us all up. There was shuttles going back and forth to the summit all day on transit day, and I took one of the shuttles up to the top, and very few people had set up because the winds up there were insane, 60-mile-an-hour winds. But a few people had promised to go up and do video feeds, so they're up there freezing their tails off. Just about 0 degrees with a 50-mile-an-hour wind. That is flippin' cold. And the air is a little thin up there, which makes it a little tougher to handle. Yeah, it's a little rough. The crew I was with, they gave us little cans of recreational oxygen. It's a little can that looks like a spray can that you use to spray on your grill for barbecuing. And the only difference I could see is it said on the side, "Not for therapeutic use." This made it recreational. It seems to be inhaled Red Bull. But it was a nice little security blanket to have, because on the bus I went up with, 3 people collapsed on the summit. So, I mean, it does happen up there. You're just under 14,000 feet, and it's 60% of the oxygen, and it is tough. You step out of the van, and it's sort of, holy crap, I've just worked hard. Now I'll take another step. Sure, this should be good. Anyway, it didn't feel too bad, but down there, keep track of the transit with video imagery and solar funnels all over the place. So even while you're out poking around and looking at astronomical heaven, oh yeah. I mean, if this isn't the mecca for astronomy, what is, right? Right up here on the top, you've got the NASA Infrared Telescope Facility, the Canada-France-Hawaii Telescope with its broken shutter. This broke actually back in April, and they just barely were getting it fixed by then. Gemini North, the light switch here is actually the University of Hawaii 2.2 meter. And the probably not long for this world infrared, UK infrared telescope, and down here the little educational telescope for University of Hawaii. That's right up on the top hill. And you can see down here where the storm has passed the island because all the cloud deck was rising busily towards the summit. Little view of Keck from there, and this young lady scurried out of her bus, came out, grabbed 2 pictures, said something loud and frightened in Japanese, and ran back to her bus. So I put this up on my website entitled Burr, which was a pretty good description of it. Over here we've got the Keck 1 Observatory, and this sucker is huge. The visitor center's there, and it's a pretty underwhelming visitor center. You have a little place where you can get some brochures, and then there's this little tiny plexiglass window that looks into the telescope, and the plexiglass window is filthy, so your opportunity of getting a good photograph is somewhere between 0 and none. But it's a visitor center. Yeah. Those solar funnels, I don't know how many of you guys had a chance to try these, but these are really cool. The imagery isn't very good, but it's nice, and you get to show it to a whole bunch of people, so I'm planning on using this for solar outreach later on. These folks were just huddling behind anything they could get for shelter. Yeah, there you go. There's Venus. So this was fun because you could walk around and check stuff out and then come back and just take another peek at how the transit was going. So this is really cool. You can observe the transit and look at everything else while you're at it. A few more bits, and over here is an intriguing sign. That's how it reads. Notice the drive with care. It reads, it's misspelled. This does not inspire confidence. I watched people out there painting the signs by hand, interestingly enough. So I'm assuming that somebody was up there with what actually on the summit, the guys working on the summit called it the stupids too. I mean, your brain just dies up there. It really does. I got a camera strap filed around my neck, and I was just, this shouldn't be hard. This really should not be hard. Tab A, slot B. This is like an educational toy. And I don't even have kids. It's just incredible. So cut the poor guy some slack. And there, take a look at this, just the cloud deck just rising towards the summit. This is a pretty unbelievable shot. Mauna Loa is right over there, so you're looking at the other monster volcano on the island. Just slightly below the height of Mauna Kea. You're right stuck between the middle of the 2 biggest ones. And down here, Submillimeter Valley. All the submillimeter telescopes are down here. This one here is the James Clerk Maxwell telescope. Oh, stop it. Behave. Thank you. In which Canada has an interest, and since the UK has pulled out, this one may not be long for the Earth either. UK has pulled out funding, and so has the Netherlands. So this is in dire straits. If the funding lapses, the University of Hawaii gets first crack at taking it. If they don't want it, it has to be removed and returned to its original state. Yeah, not good. This makes lovely sense because it costs practically nothing to mothball it, but anyway, never mind. Down here, the submillimeter array, which is a really cool telescope. Now, we weren't sure what was going to happen for the egress phases. The cloud deck was rising. We were originally planning to observe from the summit, but at 60 miles an hour, there's just no way you're going to set telescopes up. We were going to observe from the visitor's station, but the clouds were rising. So the organizers ran around madly and found an alternate location, which turned out to be the beach behind the hotel. And so we sucked it up manfully and, left a bitterly cold mountain for a tropical beach. We gave our all for science and endured the terrible hardship and raced back down. Now, this is odd because I discovered everything on Hawaii is open air. So the front of the hotel was open and the back of the hotel was open, and you went that way to get to the beach. So you've got a whole horde of people leaping off a bus with about 20 minutes before egress, all wearing stuff from the mountain, which was about 0 degrees, racing like a herd of elephants, racing through this nice hotel, carrying telescopes and stuff. And God help anybody who was in the way because some guys are ripping off sweaters and jackets because it's already way too hot, pulling out telescope gear while they're racing through the hotel. And, oh, man, that must have been quite the sight. We finally got down and got set up, and while we're sitting there waiting for third contact, we're hearing a sky and telescope people, move over to the next location. And of course, we're sitting here waiting for third contact, and the general reaction was, get stuffed, we ain't moving. We discovered afterwards why they wanted us to move, because we all set up over the sprinkler area. Yeah, fortunately the sprinklers didn't get on, but apparently I was told that they actually scurried to find the valves to turn it off. So that's why they wanted us to move. And of course we said, to hell with you guys, we're looking at astronomical stuff, go away. So I got a few keepsake shots. I just put a crude solar filter over my camera, just some keepsake shots just for myself, because I knew guys like Rolf would get good ones that I could then steal shamelessly from the Ottawa Centre website. However, Rolf, I will ask permission before I steal it shamelessly. But this is kind of cool, being able to see the whole thing. And the ingress and egress phases were absolutely beautiful. Down at the beach, the conditions were, the seeing conditions were awful. But I mean, who cared? After seeing part of this, being able to see the end of it was just monumental gravy. One of the fun parts is I was working in white light. All the guys working with hydrogen alpha saw first contact about 30 seconds to a minute before the white light guys did, because you could see Venus entering the chromosphere. And we had to wait, us white light guys had to wait for the photosphere, so we got advance warning. And that was really cool, because you knew when it was going to happen, and you were primed to catch second contact before it happened, so you could catch it just at the first hint of seeing it. I mean, it was a real advantage. And of course, they got back at us because they got an extra 30 seconds to a minute of transit afterwards. So all of us are saying, fourth contact, that's it, it's over. 30 seconds later, you hear all the hydrogen alpha guys saying rather snottily, fourth contact. Yeah, go away. Shut up. Go away, kid, you butter. You're close to the beach. Somebody might do something to your expensive. I couldn't believe it, man. I was the poor kid there. Definitely poor kid. I mean, the people I was traveling with were incredible. Some of them had just come from watching the annular eclipse. A few more were heading off to, one guy was heading off to Guadalcanal for a battlefield simulation or something like that. I had Skywatcher telescopes next to me, and another guy with probably $89,000 worth of camera. And so, what do you have there? I have my $300 AT-66 telescope. Oh, and I have my $70 camera on a little thing that lets me take my own picture. Oh, I'll go leave now. Yeah. Crap. Yeah, that says it. So I stuck around for a few more days, and one of the things I'd done is pulled every string I could get to see some cool stuff while I was there. But one of the things, if you ever get a chance to go, sign up for one of the commercial summit trips, because they're really nice. They're not terribly expensive. Somebody drives, you get to look. In the group I was with, I was the only guy that was there by myself. My wife didn't go with me because she cannot travel. She's too claustrophobic for planes. So because I was the only single guy there, sort of, they put me in the front seat of the van. I went, manfully and put up with the best seat in the entire friggin' van. Anyway, never mind, sorry. I gloat. But, you'll get up, they'll take you up, you'll have dinner, and then you head up to the summit. Somebody else does the driving. You get some nice stargazing at the end, so, it's definitely worth the trouble. This is just a little bit up from the mid-height stations. This is about, oh, stop that. Behave. Behave. Do what I wanted, not what I told you, you stupid thing. Yes, anyway, I'm a guy. So you're looking down onto the access road. This little thing down here, actually, this is a really intriguing little thing. I wish I had a chance to explore it. This thing is called Pu'uhuluhulu. Aren't you thrilled? I practiced. It means hairy hill, and what this is it's a little tiny cinder cone that's been surrounded by a lava moat. So the only thing that's here is indigenous Hawaiian vegetation. None of the invasive stuff has come in, so it's a really cool little area. You can get a nice little close-up view. Down here you've got the visitor station, which is basically an overpriced gift shop, but they do run free stargazing most evenings. And down here the old construction camp for building the first summit observatories. Most people miss the radio telescopes on Mauna Kea. So this one is just hiding at about 12,000 feet, a 25-meter very long baseline array. This stuff, the guy that led us up here, he was actually a guide for Canada, France, Hawaii Telescope, remote observer actually. This stuff is cinder cone, and this is volcanic cinder. The stuff is all sharp as a bloody rock. It's very hard, but the crazy thing is the whole area is spongy. It's like walking on sand. And at 12,000 feet, it tires you out in just steps. One of the guys on this particular trip was a group of French astronomers who'd gone to Haleakala to observe the transit and did everything with sketches. And I've been waiting to see the sketches on their website. He fell on this stuff and cut the heck out of his hands. This is nasty, nasty stuff. I assume it's down at the 12,000 foot level because it's radio quiet, but you don't see this from the main road. Another view into Submillimeter Valley, which is what they call it locally. Up here was where they put the first observatory on Mauna Kea to test it and see whether this would be good for observing. So right down here you've got the Caltech Submillimeter Telescope, the James Clerk Maxwell, and the array here. The array is quite cool. It's a whole bunch of 6-meter antennas with a whole pile of pads, and these are basically like phone jacks. This little gadget here picks up an antenna, drops it down on the phone jack, and it's just plug and play. They can completely reconfigure this array in a couple of hours. The ropes up here are for good reason. These suckers move under computer control, and it is dangerous in here. I watched some of these things move, and they're moving without warning, and you do not want to be around when those things move, so you definitely don't want to go in. They're just opening up all the observatories just before sunset. So down here you have Keck 1 and Keck 2 just opening wide and saying, oh, stop that, behave. Right down here, actually, you've got the island of Maui peeking up through the clouds. There's Haleakala right up there.
Sure those aren't webcams on your laptop?
Yes, they are, as a matter of fact. And they took pictures of you sunbathing. Down here, we've got Gemini North, Canadian Presence, and the Canada, France, Hawaii Telescope. And I happen to think these are two of the most beautiful observatories on the planet, but I could be a little biased. Oh, stop this. My buttons are bouncing. On the 7th, I had an incredible opportunity. Actually, when I was going up on my commercial tour, my telephone rang, and it was, oh, hi, I'm David Woodward. I'm a remote observer at Canada, France, Hawaii. You want to join me at 4 tomorrow for a tour? Nah, I don't think I'll bother. I'm going to go sunbathe. Yeah, right. Sure, I was there. And shortly after that, it's, oh, hi, I'm with the Gemini North Observatory, so we've got your tour scheduled for Friday. Are you okay with that? Yeah. So everything, all the contingencies I came up with came true. The Canada, France, Hawaii Telescope Tour was just incredible. This guy was a remote observer there. He used to be a telescope operator. He'd been on the mountain for over 20 years with different observatories. So up from the catwalk is a really gorgeous place to observe sunset because you can immediately go from seeing the shadow of the mountain projected onto the cloud deck to just move a few feet down the catwalk and get this absolutely spectacular sunset looking down onto what's known as 10-meter ridge, where the 10-meter telescopes and then the little dinky 8-meter telescope here and the dinkier 3.7-meter telescope. Yeah, right, dinky. So this is an incredible thing. The winds up here are unbelievable. Even with low winds on the surface, the winds up on the catwalk are always strong. Stop that. These in-camera panorama things are just absolutely fantastic. So you can get a really gorgeous sunset. These things here, this is really cool because we were watching them do their checkouts from the Canada, France, Hawaii Telescope. These shutters move so rapidly that you just turn away and blink, and they've changed position. The dome here moves faster than the dome we have outside. And if you take a peek in here, you've got a little view of the 10-meter telescope inside. The actual summit of the mountain is right down here. And if you look really carefully, there's a couple of people who are just flaked out here. They'd started climbing just as we went in, and it took them about 20 minutes to climb to the top of that. It's only about 100 feet, but it's that horrible spongy stuff, and in fact you're asked to not climb up there because there's a shrine on the top, and there's been a lot of friction with old Hawaiian folks who really don't want the 30-meter telescope to go in, so they're on their best behavior now trying to smooth relations over. Apparently the word from the governor of Hawaii is to heck with them. We're building it anyway because we need the money. But the guys who run Mauna Kea like to be a little more diplomatic. Yeah, there was somebody in my commercial group who obliged me with a picture of me looking like a complete and absolute and incredibly satisfied geek, which was a pretty fair representation. That is actually my opera glasses. Yeah, all right, fine, it's terrible. The Gemini North, this whole section rotates. You can actually move it with one hand. No, they didn't let me try. I wanted to, but they said no, slapped my wrist and moved me off. And this tiny little deceptive thing up here is actually a meter across. So this is a pretty incredible device. Canada, France, Hawaii right next door. I mean, this is only 3.6 meters, but this is an enormous telescope, and I happen to think it's absolutely gorgeous. It's sort of like a little miniature but much prettier Hale telescope. It's an equatorial, so there's the polar axis drive right there, and all the, oh, come on, what am I doing wrong here? This is only my own, stop this. And a whole set of very quick change instruments in the bottom. And up here, what used to be the largest CD imager on the planet, it's now been superseded. But this is how the Canada, France, Hawaii telescope keeps punching above its weight. These guys do some incredibly innovative imaging stuff. And they tend to test out stuff far before all the other guys in the mountain do. So after this, well, you've got an active volcano on the island. Several of them, but one of them's really active. So I decided, let's take a tour from a helicopter with the doors off. And I put a little GoPro thingy on my head so I could photograph the whole thing. Buying this was fun because I went in and bought it, and the clerk was sort of looking at me oddly and said, yes, I know, I don't look like a guy who'd use a sports camera. But they took my money anyway. But this was a cool way to observe the trip up to Mauna Kea and this trip through the helicopter. That, by the way, he's not being rude. That's actually a shaka, which you do like this, and it's supposed to mean goodwill. And I didn't want to try it in case this was something to rook in visitors. You know, you do this to the big guy who says, what? You said that to me, and, you know, promptly pounds. So, but actually, it turned out that this guy wasn't. I mean, he must not have been because I'd just given him a $20 tip. So maybe I was supposed to give him a $40 tip. I don't know. Couldn't figure it out. But looking down on Kilauea is really, really cool. And with the door off the helicopter, well, I said feel the heat back here. They billed it as feel the heat. I thought this was advertising garbage. It isn't. You go from 16 degrees, the first time it was cool, other than on Mauna Kea the whole week. And over this, it feels like you're in front of the fireplace. Literally. It's just as warm as being in front of a fireplace. You can actually feel yourself start to sweat. I kind of wanted marshmallows. Down here, unfortunately, I couldn't get a video of this. The GoPro lens is too wide angle, and my little handheld camera was just shaking too much. But you can watch the lava flowing from one side to the other about as fast as a river. Every little bit you're seeing smoke down here is more lava. This whole surface is about 1,500 degrees, 1,000 to 1,500 degrees. And then I drove down to the volcano observatory to get a peek of this from the ground. So this is an incredibly cool place to look at if you ever get a chance to do it. The open door tour is just absolutely fantastic, and it's not even very expensive. Well, it is, but the whole damn trip's expensive, so who cares? Yeah, there you go. There's the lava. And there wasn't even, this was a small amount of lava. Earlier that year, this whole area was open with lava. This is all about a month old. All that land's about a month old, which is, I find, really cool to contemplate. So there you go, folks. My opportunity to go down and observe a transit, which was absolutely fantastic. Check out some of Canada's astronomical stuff, which is even more fantastic. And do some fun stuff and not even get very sick. Of course, I'll be paying for it until the next transit, but that's another problem. Cheese! You guys can prove to my wife this works.
I don't know if I would have bought that story. Trip of a lifetime, though, eh?
Yeah.
Awesome. Thank you
Unless,
for.
of course, somebody wants to fund me for my second trip.
Okay, for the next transit, count me in.
Oh, okay.
All right. All right. Thanks for sharing that with us, Tim. And again, without further ado, Brian, you're up next.
What exactly have you got up there?
You've got some.
Roll it, Tim. What is it? Is it the film or is it the
Yeah, we got the
These are
film.
still images, so these are,
No, this is the film. We just click on it and it'll go.
oh, okay.
He says
I
positively.
thought we'd seen that before, hadn't we?
No,
Okay. Remember this?
from our exercise back in May, right?
My, they're drawing fast.
That's why I wear the beret.
Ah. Remind me, Brian, what was the idea here? Everybody came up and drew some feature?
Yeah, we had a moon map alongside, and
Right.
it was everybody had to try their hand at sketching a lunar feature.
So what did they do? Did you assign a feature or did they pick one?
No, they went and picked their own. Yeah,
And pick their own colors and all?
yeah.
I mean, let's explain
Well, that's
that.
the thing, you bring lots of colorful markers to use, and time to play. There was the moon. And that was all done, I think, in like 7 minutes or something. We did it during break.
Yeah.
Yeah. It was kind of fun.
Should we just let the stills roll?
Yeah, do you have the stills there?
Yes, we do.
So my friend, well, they're going quite quickly. Can you slow that down? That's,
Actually, Chris had them set
oh, okay.
Oh,
at 1 second intervals.
Because there's only I think it was 39 shots or something there. You get some real artistes there. I like it.
I noticed you didn't have a rent-a-beret stand, though. The Emulate Brian competition. Cool.
And our youngest artist won a prize, I believe. eh? Junior
Yes.
won a
Oh,
prize,
yeah?
too.
Yes,
Cool.
fun exercise. All right, Brian, do you want to run with your second part?
Do you want to do that now, or?
Sure, absolutely.
Okay.
Yeah.
Oh, sorry, thank you. All right, Mom, you ready to roll?
Yeah.
So I tried to go to Hawaii too. My wife said, no, we're going to Quebec. We're on our way to St. John, New Brunswick to do a little bit of family history research, and then backtracking to Quebec City for my Navy class 40th anniversary reunion. So we trucked through Montreal and went down through Sherbrooke and across to, there's Lake Mégantic here. You've gone way too far. There's a park right here, and there's a little town here, La Patrie, and this is where the observatory at Mont Mégantic is. All right, go to the next one, please. So as you approach the area, you get all these nice flat fields. You're in you're southeast of Montreal. The observatory is up here somewhere. This is it's the highest point in Quebec that you can reach by car. So that observatory was set up in 1978 and was set up for the University of Laval, University of Montreal, and McGill University. So it's a research grade observatory, obviously. So this is looking from La Patrie. What's interesting here is that the whole area is a dark sky preserve. This was the very first international dark sky preserve that was ever established in the world. And that was in 2007. So all the lighting around here is all under strict control. And the observatory had to make a case to the International Dark Sky Association of exactly what they had done, what they're hoping to achieve, and they did a good job there. So the observatory is just sitting, I think, right up there.
Do you know the elevation of that, Brian?
I do. It's 1,100 meters. What were you at? 2,400 meters?
2,400 for the observers station and 4,200 for the summit.
Oh, 4,200 meters. That's right. So I mean, I was just a quarter of that altitude. But it was still. I mean, you're lying on your back going up on this bus. You'll see in a minute. Okay, let's go to the next one. So this is down below. There's a visitors center, and then you come up to catch the bus. I don't know why the bus has to come right back down the hill, right past the visitors center. So I don't know why they didn't pick us up there. But the previous slide there showed there's an Astrolab activity center, and whoops. All right, it has an activity center in there, and a nice, beautiful sundial outside. So we all climbed aboard that bus and headed up. And this is what you see on your way up. It is one of the queerest looking observatories I've ever seen in my life. All right.
It's a Dalek.
I mean, who invents stuff like this? I love it. I love it. So like I say, that was set up in 1978, and we'll go to the next one here. And it's windy as everything, just like you experienced with the winds up there. Extremely windy on top of the mountain there. So you get a nice guided tour. She knew her stuff. The tours are in French only. So you can see on the back of it's a big yoke here and all that, and you can see on the back of the telescope where all the instruments are. We can never see the front end of the telescope. They wouldn't They wouldn't let me even go up to the next level up just to take a photograph down to do it, but there it is. They have shutters as well to equalize the temperatures inside the observatory, and it's quite noisy up there. You hear things rattling, and if you were going to be working there late at night by yourself, I hope you don't have a really vivid imagination, is all I can say. Now, just about where she's standing, like right over here, there's a section of the deck there that can drop out. If we go to the next one, I think that's another, that you see the mount there. All right, so now we're down below from where the telescope is. There's the hatch that opens up, and you know what that is? Right? You know what they do with that? When they have to re-illuminize the mirror, they put it in there. It's a vacuum chamber. So you have little bits of aluminum, and the aluminum spreads then across the mirror. So there was a slideshow going on at the same time. All the visitors are sitting over here watching this. I'm cruising around taking photos. But what they do is they roll this over this way, lower the telescope mirror down onto this, then roll her back, throw the hat back on, and they do it. And they do that twice or once every 2 years. Now they say they give you these little factinos on the website. It says that all this telescope mounting and everything weighs 24 tons. I'm thinking, what a stupid thing to say. Who I don't know who's going to try lifting it. You know, it's nailed to the ground. That's all you need to know, right? In 1991, this observatory was the first one to use an infrared camera. What else? That's about it. It has an asteroid 4843 named after it. But it's nice. You had a nice tour up the mountain. They got a nice visitor center down there. Is there anything else?
What's the size of the mirror, Brian?
Oh, it's a 1.6 meter diameter mirror. Take us to your leader. Now, an interesting little thing here, and this is the last thing just before I shove off. All the ground around there, because they kept the observatory painted white, that's to reflect heat away from the observatory so it doesn't heat up during the daytime so much. All the ground around the observatory, they've trucked in white gravel to achieve the same effect. I think I have a piece of it. Not here. So I didn't put it in as a door prize. It certainly wasn't as I mean, there's a nice piece of rock down there, but... All right. Anyway.
And again, I ask, we're going to move into our observation session, and again, I'm going to ask folks to keep it brief. Okay? Oh, I have the controller. Here we go. We have an excellent collection of imagery from a number of folks there, so without further ado, first and foremost, Mr. Commission, what have you got for us?
I've got 3 sets of interacting galaxies. This is known as the Mice. It's located in the Coma Berenices constellation, and this is a relatively difficult one. It's the top one is 13.8 and the bottom one is 14th magnitude. So you need a fairly good telescope to see them, let alone photograph. It's a 15-minute exposure on a 14-inch telescope. Next, please. Okay, this is NGC 54, 26, and 27, and they're in Virgo. They're interacting, as you can see, there's the bridge between the two of them. This is a 20-minute exposure. These don't have a name, a particular name. And then there's the third one. Next, please.
Oh.
Okay, those are the antennae, and they're situated in Corvus. They are a little brighter, 10.9 and 11.1. This is a 12-minute exposure. As you can see, they're interacting again. There's an interaction between the two of them. You see those white strips. So if you people will be willing to wait another 5 billion years, I'll show you the picture of how Andromeda and the Milky Way interact. Thank you.
Thanks, Paul. All right. Next, we have a series of images, very impressive images from an impressive young man. Jacob, would you like to come up and tell us about what you've got? Can't kill him up.
If you're okay here, I'll go back and select.
Hi, this is a relatively old image I took of the North American Nebula. It was taken the August of 2011 at Charleston Lake. I miscalculated the time the moon was going to rise, so it rose about 4 hours earlier than I expected it to, so I ended up capturing more moonlight than starlight, so the processing ended up kind of noisy. And it was just a stock camera, so the hydrogen alpha didn't come out great. So after I modified my camera and got a hydrogen alpha exposure, I decided I wanted to enhance it by gathering hydrogen alpha data and replacing the old, very, very noisy, low signal red channel with the new hydrogen alpha channels. So here's the hydrogen alpha data I captured. It was only 4 hours. I could have gotten a little over that, but of course clouds moved in. It was forecasted to be a 5 out of 5 seeing night. This is all 10-minute exposures from my Skywatcher Equinox 80 prime focus. There's a hydrogen alpha filter. The beta are 2-inch 7 nanometer. So when I combine the two, I used hydrogen alpha for the luminescence, and I combined it with the red channel. And as you can see, it's much, much less noise, and the hydrogen alpha is very much brought out, and the contrast is greatly increased, making a much more pleasant image, something I'm much more happy with. Later on in the summer, I captured this at Bruce Peninsula National Park. On the western shore of the eastern shore, you have Lion's Head, which is an official dark sky town. So this image is from the western shore on the beach, so the seeing wasn't great, which created the fuzzier stars than I usually get, but it was taken with the same setup minus the filter. It consisted of 3 hours of 10-minute exposures, all at ISO 1600 with my modded Canon 1000D. I would have been able to gather more, but the telescope hit the side of the mount, which didn't really matter in this case because the noise was actually very reasonable. So instead I went and captured another 3 hours of darks afterward. Later on in the early August, I decided I wanted to go after the Pac-Man. I planned this as a project where I would actually gather hydrogen alpha, and then later planning to get RGB later at the next new moon. So this was taken a day after the full moon. That night I managed to gather 5 hours and 20 minutes of exposure, 10 minutes ISO 1600, same setup as the hydrogen alpha for the North American Nebula. Except that image came out fairly noisy. It's not this image, more data went into this image. It came out quite noisy, and there was a huge amount of dark noise because the darks were taken out too cold of a temperature. So a few nights later, I went out on a night that was fairly similar to the temperature I took the lights at and gathered new darks, trying to regulate the temperature of the camera using third-party software that could extract the temperature data that Canon hides within their file that they make very, very difficult to get at. So and regulating involved trying to fan air onto it and firing the shutter just to heat it up, trying to get it to the right temperature, and in the end that worked. But there's still a fair amount of other noise, shot noise, read noise, which I wanted to reduce. So on another clear night, I went and gathered another 5 hours and 10 minutes of exposure, bringing the total up to 10.5 hours. For that image, I recycled darks I had taken a while ago, which were at similar enough temperature, and I managed to produce this image. This is taken with a one-shot color image. That's why a lot of exposure was required, because I'm only using a quarter of the pixels on the 10 million pixel chip, so only 2.5 million pixels. So as planned, the next new moon I went out to Nirvana, where Jim was there with his very nice 18-inch telescope. So there I managed to capture just under 4 hours of exposure, 3 hours and 50 minutes before something went wrong with the guiding and it was done for the rest of the night. But that was enough to get a very decent image on the object. I'll show you that now. So this image here, the dark side, I recycled this dark side I had taken before that was about the same temperature. As you can see, the stars are slightly blue around the center. If you look at the blue channel, they're very much bloated around there, but everywhere else they're pinpoint. I'm not sure what's causing that. At first I thought it could be chromatic aberration, but all the other stars were very good in the blue channel, and I've never had this issue before with the same setup. So when I went to combine the two images, it was to increase the contrast and help the red channel. So what I did was I took the hydrogen alpha and layered it over the red channel, giving 60% to the hydrogen alpha, 40% to the red channel, and replaced the original red channel with that, and then took that same red HA composite and used that as a luminescence all in Photoshop to produce this. Much higher contrast and much more hydrogen alpha because of the hydrogen alpha data. It really helps the image. It's not shown here because it's much more recent, but I was experimenting trying to reduce the bluish stars in the center by compensating the green channel within to the blue channel, which does help, but it messes up the star color, which is going to take quite a while to figure out how I can fix that. But for now, I'm quite happy with this image. Fair amount of hydrogen alpha and detail of the dark nebulae, especially since I was using a one-shot color camera with hydrogen alpha. And that's the final image.
Well, thank you, Jacob. Most impressive work.
Is that all with a DSLR camera, or?
Yeah, that was all with my 1000D.
Okay, next up, Gordon. Sketchmeister.
Okay, I got to start off with a carbon star here, RW Cygni. It's done back in June. Next, are you doing it or am I?
Yeah, if you want.
Okay, if you will. Now we have RS Cygni. This one is done with my 12-inch. Now, when I'm doing colored stars, I've tried a bunch of different things. I've tried actually using colored, a limited series of colored pencils in the field, but you're drawing them on white paper, and then when you invert it, then you've got the negative colors, and it just gets all very complicated. So what I've started doing is just making notes in my logbook, and then when I get around to inverting them, which is usually a week or 10 days later, adding the color. And I've always wondered, how my memory is serving me. Sorry, what was I talking about? But anyway, when I went to save this file, it up came an existing file with the same name. Can we go to that one, please? Okay. And this is from a year earlier in the 8-inch. So you can see there are more stars in the 12-inch, but the colors are almost the same. So, not too bad.
Sorry, I'm trying to get back to your first one.
That's okay.
There we go.
There we go. Red's a little more intense, but pretty close. Pretty close. It was the bluish one that I was more concerned with, because that's the harder color to judge. Okay, next we have NGC 1609, planetary nebula in Delphinus. Okay, Delphinus. Okay, it's done with it's done with a 120 refractor with an 03. Okay, it's got a slate blue tint to it and a good bright center. Next, we have 6871 in Aguila. 6871. No, sorry, my notes are out of order. So yeah, 6871, an open cluster in Cygnus. Okay, and next, there we go, 6781, planetary nebula in Aguila. And it was really interesting because it had this annular shape, and I was flashing back to Hoag's object that we picked up back in May. But there's actually more stuff in there in the middle, I just wasn't seeing it. But it's really bright on the one side and not quite so bright on the other. And just when you thought it was safe to look at things again, transit of Venus. Okay, we took the telescope and we set up on a little near the bike path along the Ottawa River out in Orleans, and so we had lots of people stopping by. But I managed to get this around 7:30.
That's nice.
And yeah, we're really good on the sun, but they're not quite right, but yeah, looks good. And then, as a lot of you will remember, it started to cloud over shortly after that. And when all the people looking let me get back to my telescope, I couldn't get a photograph, so I had to do it from memory, and I did it with colored pencil and then went in and smudged a bunch of stuff with the software. That's it.
Thanks, Gordon. All right. Oh yeah, this guy. I've just got a few things for you. I'm going to speed through mine. Perseid meteor shower. I don't know how many folks had a chance to look at it, but we did have a reasonably good display. Managed to catch a couple of bright ones. This is one of my better catches there, and that's just a camera on tripod that took a series of still images there and managed to get a very nice bright meteor going through there. So, and that was actually the night after the the peak there. So that's a nice wide peak on the Perseids there, and you can see it for a few days running. Okay, shot of the Crescent Nebula. Again, this is one of the other images that I shot with the borrowed 60 DA camera, which I've now had to return. But it was well worth it. I thank Jason Coley for lending that to me for the length of time he did, and I'm sold on it. You want a DSLR for astro imaging? I don't think you can get much better. So very, very impressive camera. And that's a single 10-minute exposure. So it very, very pleasing results with that. Went to Starfest with a number of folks there, and I haven't had a chance to really process those images there, but we did get a very rare aurora that extended like right down to the ground. Have you ever seen anything like that? Is that cool or what, eh? Isn't that amazing? Very, very rare. Actually, the hooligans that I was with, of course, had to whip out their green lasers and see who had the brighter one. And yeah, this is... So we were making artificial auroras, and I just kind of turned away and walked away in disgust, beer in hand. And they said, "Stop or we'll shoot." I stopped. I put up my hands. They shot me anyway. There you go. Struggling me. Yeah. We won't mention any names, right, Glenn? So there's yours truly before I died because of laser blasts. And then, of course, they turned their interest to astronomical objects. We want to, of course, start a war with the Pleiadians. So we were shooting the Pleiades. And, of course, we were shooting the trees, too, because, yeah, well, they're hostile. They've got to go. But the reason I wanted to show you this is we did get a really, really neat catch, because the next target we wanted was Jupiter. And this was Jason playing with his now returned 60 DA. We set up the laser for Jupiter. He just turned on the shutter, and we got this. And it was so close to turning on the shutter, I said, "Jason, I think you just got that," because it was bright. This was a fireball, and you'll see in the close-ups there, it actually flashed 3 times, and I could see that. I was looking right at it, fortunately. And we weren't even sure we got it there, but we did, and it was brilliant. There's just a couple of zoom-ins on it there. You can see the little pulses there, and I've got one more. Yeah, you can, and I could see these. Oops, sorry. It pulsed 3 times, and it was very, very obvious there. And you can see there's actually some ghosts on the stars there. We got so excited, Jason actually managed to kick the tripod. But obviously the meteor had already passed, so it was unaffected by that. Anyway, that was a fun catch there. This is what you do at 4 in the morning after you finish taking your serious pictures. You don't want to go to bed yet, so you start zapping things with a laser. So that's all I got for you this month. We did do some serious work out there, and with no further ado, I'll let that guy talk about what he did there. Now you see what he did. Glenn?
Yeah, if you don't have time to spend hours getting your lights and your red, green, blue channels and darks and so on, you can do astro imaging the simple way with a highly sensitive camera. There, a couple meetings ago, you saw some of my results where I had slapped my Mallancam on Paul's telescope, which is an Altaz go-to/tracking Dobsonian. This time at Starfest, I brought down a newly acquired, used Ultima 8 C8 telescope, Schmidt-Cassegrain, and I got a Meade f3.3 telecompressor to get a nice fast focal ratio, a wider field of view, and was shooting some reasonable good images with nothing more than a light pollution reduction filter just to get rid of some natural sky glow, as well as some of the light dome over the Golden Horseshoe down to the south and southeast directions over Toronto. And I just got a selection of a few of them right here, and we can just advance through at my command. That's the Lagoon Nebula. Now, once again, these are not high-res, pretty picture type things. It's just an NTSC format video chip, so it's in the 640 by 480 pixel range, something around 300,000 pixels. But the thing is that it's very sensitive with the amplification circuitry built in, and of course this Mallancam, it's also cooled, so you can get the thermal noise down as well. And it's a way to get images in very short times. These shots are between about 30 seconds and 56 seconds each, with just a single screen grab of a frame, as they were generated into my little laptop one by one. And then the next one should be the Trifid Nebula, when we don't skip too fast. So you can see both the emission red component and the nice little bluish reflection component that dominates to the north side of the nebula. And incidentally, the fields of view on these images are all the same. I haven't done any cropping. The moon would just about fit into the width of the field of view, just to give an idea of scale. And the next one, as we move a little further up north along the Milky Way, more or less, there's the Swan Nebula, or M17. And then next is the Eagle. And you can see reasonably well enough the so-called pillars of creation made famous by the exemplary Hubble image that was released not too long after the instrumentation had been fixed with the new COSTAR system. And then next up is, perennial observing favorite, one of the brighter and larger planetary nebulae, M27. Next. And here is the nearest, and hence the largest, readily observable planetary nebula in the sky, the Helix, or NGC 7293. In here, the background sky glow is a little bit reddish because the looking somewhat low in the southern sky, the light pollution filters still let in some of the obnoxious redder component of the sodium lighting over the big smoke down to the south. And incidentally, in the upper left corner, that's amplifier glow, which is the kind of a thing that tends to show up when you've got longish integration times with these cameras and you've cranked up the gain to help bring out the image intensity more. It just shows you some of that glow, which is kind of related to thermal, but I'm not exactly sure on the physics behind the precise cause of the glow. But if you just ignore that, or if you want to get fancy, you can do dark frames and subtract them out to get rid of that amp glow if you want to make something a little more attractive. Next is the Veil Nebula, the supernova remnant in Cygnus, and this is the northern part of what's commonly called the Witch's Broom. It has the most well-defined structure where the supernova shock is slamming into the surrounding interstellar medium, and the little green streaks, those are excited oxygen atoms glowing just from the energy of the shock.
You sure it wasn't you with a laser pointer?
I wouldn't have been able to hold it that steady, I think, at that scale. And next, we have a portion of the other side of the Veil Nebula. And next is, you saw a finer image of that just previously of the Crescent Nebula, NGC 6888, just the result of stellar winds from a Wolf-Rayet star slamming into the interstellar medium and shocking the hydrogen atoms primarily into fluorescence. And next, this here is one of the elephant trunk features in a very, very large nebula that is far larger than this field of view, IC 1396. And it's just caused by a star a little bit out of the left of the view whose stellar winds are sculpting this little dark molecular cloud remnant within this large bubble of nebulosity. It's a commonly imaged object nowadays, it seems. But what's interesting is that here, with nothing more than a light pollution filter and one of these little cameras in a reasonably dark sky, in a little less than 1 minute, you can actually get a usable image of it. Next. Here's just a two-frame composite of the Central America part in the lower right and the Mexico portion in the upper left of the southern part of the North America Nebula. The molecular cloud material is off on the lower left, which is why you have those bright rims where the ultraviolet radiation from the exciting star system is baking the molecular cloud and driving off the gas, exciting it. You just have a little higher density of that. There's also sulfur emission there as well, contributing to the bright rims on the edges of those clouds. It's a common feature around the periphery of new star-forming regions where there's still molecular cloud material in the vicinity that's being eroded. And I guess we have one more, which is just a two-frame composite, which doesn't take in all of the famous Andromeda Galaxy M31, but I decided to put in here at the same scale. These are just cropped out portions of images. I haven't made them larger or smaller, of M51 in the upper right and M101 in the lower left, just to give an immediate sense of the massive size of M31 due to its proximity. But of course, in the lower central part of the image, that fuzzy, what looks like a star, that's a satellite elliptical galaxy, M32, which is orbiting around M31. So you can see it's intrinsically a pretty small galaxy as well compared to M31. It's a dwarf spheroidal, I guess, would be the best classification for that. And I believe that's the last one of this series. Yes.
Great.
Well, I had a question. Other than getting the images faster than through traditional methods, were there any other advantages?
Well, these cameras are fairly nice for what you might call near real-time observing. And if you live, say, in a suburb, you can actually penetrate through the sky fog well enough to see objects that are just beyond detection visually because of light pollution. So it's a way to extend your observing. If you're forced to stay in the city, you can still penetrate through with not a terribly large telescope and get nice detail on a lot of very faint, low surface brightness, otherwise invisible objects visually. That's kind of the main thing. I think RASC's intention with these was just to do it more, not as an image capturing device and save them, but to extend your observing, especially when you're light pollution bound. I think someone had a question?
Yeah, no, the great thing about the Mellencamp too is that you can project it on a TV screen. So a lot of people can look at the object at the same time. You can point at objects.
Oh, precisely, because it's just a video camera, so it's got an NTSC output that you can just send directly to any old TV, and yeah, you can do group observing that way as well.
Doesn't that interfere with your night vision, though, looking at a monitor?
Oh, certainly, but if that's all you're concentrating on is the visual display, then you're not really concerned so much about that. And if you have a go-to telescope that can bring you to your target, then you're not really worried about that, because as long as it's well enough aligned, you can find your targets without having to peer into a finder or an eyepiece, and just let the telescope do the work of getting to your targets of interest.
What is the camera again that you're...
It's just a Mellencamp. There's different models. This one's called the variable shutter speed, the VSS. There's been a newer model called the Extreme. Essentially the same, but you can computer control it and go with even longer exposure times and do a sort of CCD mode where you don't have the amplifier glow because you're not reading out in real time. You're getting the image, then reading out differently. The mechanics I'm not too sure about, but that's what they are. Just highly sensitive video type cameras with television type display output. Anyway, I guess that's enough for now. If you have other questions, I'll be available after the meeting to answer them. Thank you.
Great. Thank you, Glenn. All right, a couple more to go here. And again, I'm going to ask folks to be brief, because we're starting to push our envelope a little bit. Here we go.
Thank you. This is a black hole. That's very clear in the picture. You can see that. This star is 20 to 40 times the sun's mass. It's about 6,000 light years away, and it's 300 to 400,000 times as bright as our sun. It's about 5 million years old, which means it's about a 1,000th as old as our own sun. And it's about 20% the distance as our Earth is from our sun to a black hole. And just this one here. Yeah, that's good. You do that. This is an artist representation of this star that I just showed you a picture of. And believe it or not, it's pretty much to scale. It's about 2 times the radius of the star from the black hole. And it's being sucked off into that. And the black hole is an X-ray source, which explains the designation X in the original. And matter is being sucked into the black hole, which is giving the X-rays, emitting the X-rays. It's about 15 times our sun's mass, this black hole. It's got a radius of 26 kilometers, extremely tall. And I say radius, that's really the event horizon. And it did not supernova. It collapsed from a star that was probably 40 or 50 times the mass of the sun. It collapsed into this black hole, which is 15 times the mass of the sun, and did not supernova, because if it had, it would have blown that star away. So it didn't do that. And this thing here is best known, probably, because it was the story about a bet between Stephen Hawkins and Kip Thorne. Stephen Hawkins bet that they'd never find a black hole, and he paid off Kip Thorne in 1990 with the science that came from this black hole. Okay, next slide. This is a Chandra X-ray image of that same star. clearly, this is not the star. This is the accretion dish around the black hole. The star itself does not emit X-rays. And then finally, this is the black hole, like real close up. That's a joke, Attila.
No.
Next image. And the day I rushed out after Neil Armstrong died and thought I'd take a picture of the moon just sort of as memory. And there's a friggin' tree between me and the moon. So this is the day after Neil Armstrong died. And I've labeled Armstrong Crater on the moon. I think anybody of my generation, which is not too many of you young people here, would clearly remember where we were and what we were doing when he stepped off on the moon. We all watched it live television. It was quite an event, and I'm sorry to hear that he died. Anyway, that's it. Thank you very much.
Thank you, Bob. All right, last but not least, our busy man, Rolf.
It's the same as what Glenn had showed earlier, the M31 Andromeda Galaxy. This is a series of 5-minute exposures, I think about total of half an hour exposure, taken with a 600 millimeter mirror lens that was loaned to me by Peter Saravolo and a Canon 5D, not modified. So these lenses, this one happens to be f8, and they're typically around f5.6 or f8, are readily available on eBay for about $200. And they're very sharp right up to the edge. And this particular one has very little vignetting, as you can see. So it's a pretty good value, pretty good alternative to these very expensive specific lenses. But they are typically around f5.6 or f8. But you just increase the exposure to compensate. And I think I used about ISO 800 for this. And next, so this is that's the moon. So yeah, so I enhanced this somewhat to show colors, as well as to show a little higher contrast in the features. And oh gee, I don't know, just going by memory, I guess the Armstrong crater is somewhere in here, is it? Does anybody know exactly where it is? Is it this white thing here?
You can't see it.
Just above the...
I don't know. It's probably just at the limit of this. This is probably about 1 pixel per arc second, but actually the projector is downsampling it quite a bit, so you probably can't see it. But I did increase the color saturation somewhat. I like to do that just to see what it's like, and you can see lots of colors here. This what is this? Is that the Sea of Tranquility? Yeah, so it's pretty blue. This is obviously kind of reddish.
Put the colors in, Rolf.
Pardon?
How did you assign the colors? How did that work?
No, this is a color picture, and just by increasing the color saturation on Paint Shop Pro, you can actually see the colors. These are the true colors. There's a kind of very orange area here. I guess this is kind of greenish. This is not the most saturation that you can get, but it was enough to show some of the colors. Now, what I found very interesting here was this almost square area. Brian, what is this?
It's the Aristarchus
Plateau.
Oh yeah, it's almost square, isn't it? So maybe it shows up better when it's color enhanced, but that's what it is. And this is the darkest area on the moon, the crater Grimaldi. So anyway, so that was fun to do. And this one I just exposed longer to get the Milky Way.
That's pretty cool, actually.
No, that's a composite image, and I've been playing around with that, and people wonder, does it really look like that?
Sci-fi movies, maybe.
Yeah. So So that's always fun to do if you have some old images lying around. And actually, no, Hugo, you inspired me to do this because you did something similar a little while ago, didn't you? So is Hugo here tonight?
Yep.
Yeah. So that's what that is. So that's it.
Thank you, Ralph. Thank you. Okay, next up, Stephen is going to give us a brief update on public outreach.
Can we get some more lights in here now?
Yeah.
We're all sort of standing around in the dark. Right, so just public outreach activities, just I guess an offer request. If you're doing outreach activities, even a private star party, and you want them mentioned, or now that we're back in the school year, if you're going to go and visit a school or something and you want to get some credit with it, let me know, and I'll include this on the on our activities list. We held another dark sky star party in August. We're actually doing quite well.
Okay.
We've actually managed one star party for each month from May, June, July, and August, although, as Tim mentioned, if you schedule a star party, it's guaranteed to be cloudy. So we're trying four alternate dates each month, and had to use all four, or the fourth alternate date in a couple of times. So this is actually the July party. We've been getting at least a dozen people out with telescope, which is a really good turnout. And on nights, days where there's a clear afternoon and people have made their own decision to come out, we're getting 80 to 100 people visitors, so very popular events. Coming events, we have another dark sky party, and true to form, it's not happening tomorrow. I've already sent the note that we're not doing the star party tomorrow, so we'll use the cloud date on the 15th. We're going to use the Cumberland Heritage Village Museum site, and I'll talk a little bit more about where that is, but it's an East End site, so several people have applauded that. They've been trucking out to the West End Carp for a couple of years now. So 8:30, so a little earlier start time, and we're also only go till midnight at the museum. They are providing staff to open the gates in the washroom, so a slightly shortened event. The Museum of Science, the Aviation Museum is holding a gala dinner to celebrate Alouette 1 50th anniversary in space, and so that's on the 29th. The website with the more details there it's called Canada on Orbit. This information is also on the RASC website under the outreach page. Keep it up to date on a monthly basis on what events are coming up, and so that website's there. So it's obviously not a free event like our star parties. And then the other event I'll talk a little bit more is Science Fun Fest coming up in October. So it's a very popular event. So here at the Cumberland Museum, it's actually from central Ottawa, it's the same distance from the Cumberland Museum it is to Carp. It seems like it's far away, which is actually good because you're going to think you're out in a dark sky site because it's far away from Ottawa. So aside from the sinkhole on 174, it's actually pretty easy to get to. We've been working with the museum, and they've offered us what's called the West Field. So you enter there. The main entrance to the museum is there, so it's kind of like if you get to the museum, you've gone too far. But it's fairly easy to see, and the gates will open up around 7:30 for people setting up telescopes, and then the star party itself should be prepared to go around 8:30. So the public parking is just a little bit to the north, and people with bringing telescopes can set up. They can drive right in and into the field and set up your telescopes there. So it's quite good. They're going to douse all the security lights for us, so they're being quite cooperative. They also run their own astronomy program during the summer, and So we should be helping them out for that. And just, I guess, a plug for the museum. They're actually, their event, they're hosting a cider tasting event too, so you can actually take in both, go to the cider tasting and then the telescope event. So quite happy to have the East End. We're just doing this on a trial right now, and it's kind of a win-win for us in the museum. So I hope it works out. Science Fun Fest. This is a huge opportunity, really, for RASC outreach and volunteers in general. They get anywhere from 3,000 to 7,000 people at this event. It's geared for sort of young adults and really anyone interested in science. It's kind of set up as a more hands-on activity-based program. They get 70-some science clubs and groups and organizations that volunteer their time in the afternoon and set up in the Booth Street complex of the National Resources. So they've been doing this for a number of years, and it's a highly successful event. RASC has had a commanding presence there for the last couple of years, a couple of tables inside with a number of activities, and then we'll have a solar observing area as well outside, weather permitting. So if you're interested, let me know. My email address is on the bottom, or just the outreach coordinator from the RASC site. So just I sent out the email today, and I've already got 4 people, so that's great. But more people are required. So mark it in your calendar. It's a Sunday afternoon, or starting just before noon on October 14th. It's indoor and outdoor activities, so it will be going regardless of the weather. And hopefully it will be good, and we'll do our solar observing as well. And there's our outreach.
Is that Thanksgiving weekend? Steven? Is that Thanksgiving weekend?
Is that Thanksgiving weekend? I don't think so.
I don't think so, but...
Okay, as you can see, we're running on the edge of our course. We're going to go over, but I want to give Alan a chance to talk about this, or give his presentation. He doesn't get down this way very often there, so without further ado, Alan Ward. Sorry, we are cutting things a bit fine there, but please come on up and do your thing. Where are you? Where are you? Oh, there you are. I knew you were here. Thanks, Alan.
Hi, everyone. I'll be very brief. I'll get you guys out of here soon. Glad to be here. It's been I've been trying to make it to Ottawa for many years, but recently my mother moved down from Sudbury, living in a nice condo down the street here, and of course she wants me to come down and visit quite often, so I'm going to try to attend some of your meetings and hopefully give another talk one day on maybe on the coatings of lenses and mirrors. This presentation here is about the realm of the design construction of a 6-inch apochromat triple oil-spaced refractor, and it's about more of it has to do with about the motivation, the calibration, the collaborative efforts, and the knowledge and experience obtained by a couple of passionate telescope makers into in their quest for building a perfect visual refractor. So is this the advancer right here?
Yes.
Okay.
I can do it for you if you'd like.
Okay, that's good. I'll just show that for a few seconds here. Are many people here into telescope making at all? Show of hands. Anybody have made their own telescopes? Lenses, mirrors, mounts, tube assemblies? Okay, let's throw a few people. We telescope makers do spend a lot of time at night when it's cloudy building telescopes because it's not clear all the time. For our refractor, we wanted a few things. We had some criteria that we wanted to obtain. We wanted, first of all, an uncompromised system that was basically optimized for the visual. Most telescopes out there, most refractors in particular, are designed corrected for photographic use. We wanted a visual instrument because we found that the visual experience has been lost over the years. And we'll get around to a little bit of that as to why that happened. We wanted a telescope that was better than diffraction limited, hence we went to an apochromatic refractor, which would give us the best color correction possible with the best available glass on the market. Some of these exotic glasses are not available. They weren't available years ago, now they are. We also wanted for visual use, we wanted what's called a large depth of focus range, and that allows you to, you don't have to always chase the focus down, particularly when you have bad seeing conditions. And of course, we're building this from scratch, so we wanted the design to have some generous allowances in the fabrication. Many designs exist very, very well on paper, but there is absolutely no forgiveness whatsoever for if you're out a little bit. Like it's very tight. We call that a peaky design, and we didn't want a peaky design. Now, in order to achieve this, we had to collaborate with an expert, Roger Terrajoli. He was a chief optician at the Stewart Labs, where they build the Keck mirrors and such for 1 meter and under. And he recently published a book with Richard Berry and on telescopes, eyepieces, and astrographs. And he was very important in our quest for building this telescope. He helped us with the choosing of the glass, and he helped us with our design based on our criteria that we wanted. This book just came out, and it's available through Wilman Bell. Now, some of the motivation behind this started way back when. Sudbury is quite well known for a history of telescope makers. Back in the 50s, we had Ken O'Daysky in Sudbury, who built his own 5.5-inch achromat refractor. He had to order the glass from England. Couldn't get the glass anywhere in North America back then. And Ken was building mirrors, lenses, ever since the 40s in Sudbury. And I ran into him as a teenager at Laurentian University when the professors were putting on a public star party. So he enticed me to build my own first refractor back in '84. And I thought it was going to be quite a feat to do. But with some little bit of help and some guidance, anybody can do it. If anybody's ground a mirror before, you can also grind a lens. So this is back when at Science North we had an optical lab when the establishment opened back then. We had telescope making workshops for the public and for the club members. So it served to be a very handy facility for doing this sort of thing. And of course, that's my 4-inch f/15 refractor, which I'll be retiring soon, because I'll be building also a 4-inch Apo soon. Dennis Mayo, the guy with the red shirt, we partnered up together after building this 30-inch, 29.5-inch telescope a few years ago. We decided what's next. Obviously, we weren't going to go bigger, because this turned into a monster to begin with. But both of us had considerable, knowledge and experience in building large telescopes, large Newtonians. But we wanted something different, so that's when the refractor phase came in. Now, I want to talk a little bit about this. This is this Swiss cheese analogy is used a little bit in some presentations. And it has to do with a telescope, you have to realize that the light has to go through an obstacle course by the time it gets to your eye. It goes through basically a war zone. And you want that light to reach your eye unscathed. There's gremlins in there that'll just take away or modify the image or whatever. They'll just take away all the information from your light before leaving you nothing on your plate to eat. And all of these attenuators, as you know, can be anything from the PERD optical design to start with. You got aberrations, you got comb off axis aberrations, baffling, stray light, collimation. All these things rob your image. And if you do not go in there and get rid of these or optimize them or whatever you have to do, you're going to get blobs at the end of your tube when you look through the eyepiece. Okay, so what you want to do here is preserve the integrity of the light. And so this was what we had to do. This was a small 6-inch telescope. In order to get all of that light down the tube, unattenuated, okay, there was many challenges we had to overcome, and it hurt the pocketbook big time. Because when you want performance, you got to pay for it. Doesn't matter if you're buying an instrument or you're making one, there's no difference. You still got to pay. Now about the Airy disk, when you look at a star in a telescope, you're not actually seeing a true image. You're seeing basically a diffraction pattern, okay? Because stars are just too far away. With the sun, for example, it has an apparent diameter. You can actually, it forms an actual image. But for a star, you get a diffraction effect. And it's surrounded by, you get a bright spot in the middle surrounded by concentric rings around it of decreasing intensities. Now in a perfect optical system, without any diagonal or anything, 84% of that star's energy goes into that central spot, and that's called the Airy disk. The rest of the 16% of the light energy goes into the outer rings. 16% or 7, the innermost ring containing 7.2%, and so on. So the whole idea is to get all the light, as much as you can, into that Airy disk. Otherwise, they're going to bleed. Your star images are going to bleed out into the outer zones of the concentric rings. Hence, you're going to lose resolution, you're going to lose contrast, and so on. So the design has to come good so that all of the light falls into that Airy disk. And I'm not talking about just the center part of your field of view, but also at the edge of the field. Because you can have perfect correction in the center of your field, but you don't have it at the edge of the field. So our criteria was to have a perfectly resolved instrument up to 1 degree in field of view for visual use. Now the big challenge with the refractors, as you know, is this beast called chromatic aberration, and it's been haunting the refractors for centuries. As you know, different frequencies of light bend at different angles when they pass through the light, pass through the glass, and we need to minimize this or as much as we can so that all of the colors fall within that Airy disk. Now, remember I talked about we were optimizing this telescope for visual. I'm talking about all of the visible light that the eye can detect. All of that light has to go into the Airy disk. Okay? Some of the other light imaging photography will capture will fall off that Airy disk. And you'll have to do further different correction in order to get all of those rays into the Airy disk. Now, back in the days of the achromats, there used to be this kind of like chart that we used to use to basically, okay, what's allowed? What's permissible in an achromat so that I'm not going to see gobs of color everywhere or big, halos of color. And typically, we always think of an f/15 being the choice. But, well, an f/15 does work for small lenses, like 3 inches or so. Even up to a 4-inch, the color is still there, but it can be filtered using UV filters, whatever. The problem is that we wanted a 6-inch or an 8-inch refractor, and you can just imagine how bad the color was going to be there. Using the Conradi standard here, whoop, how do I hit something?
Don't worry.
Can we blow that off there? There we go, thanks. The Conradi standard, right here, says the focal ratio has to be 5 times the diameter of the lens. So in a 3-inch, that would be 5 times 3 equals 15. So your focal ratio would be f/15. In a 4-inch, the 4-inch would have to be f/20 to have just a little bit of detectable color. In a 6-inch, you'd have to be f/30. Well, now we're getting very impractical here. You're not going to have a telescope 16 feet long, right? So we couldn't go with an achromat. We had to go with an apochromat, and that's where the cost just jumps right through the roof now. With the availability of ED glass, which stands for extra low dispersion, that means with the light, when the light passes through a prism is basically a lens is basically a smooth prism actually. So when the light passes through the lens, you get less of a spread of the colors being spread out. That's what dispersion is called here. So with the special ED glasses out there, you can actually minimize the spread of light, and that helps a lot in the overall design. When comparing achromats and apochromatics, you can see our telescope falls right in around here, which is just slightly better than 1/8 wave, which is meant for superb planetary lenses. This is a graph that Roland Christen developed in the 80s and published in Sky and Telescope magazine. Most of the commercial apples out there fall around here, around 1/5 wave. This is comparing a 6-inch Apochromat with a 6-inch F15 Achromat. You can see that the color is quite a bit, 1.4 millimeters. That's the separation of the focusing of where the two colors, green and reds, focus between each other, almost 1.5 millimeters apart. That's quite a bit. In the Apo, it's about 0.27. So it's about 6 times smaller, or tighter. And if you do a spot diagram, this is what I mean about the bloating and the bleeding. The iridius is represented by the black circle here. And as you can see in a 6-inch F15, most of the energy of the star is now being bleeded into the concentric rings outside the iridisk. And hence you're going to lose your contrast, your resolution, so on. With the Apo, all the light, it falls right inside the iridisk. And this is showing up to a degree field, which is like half from the center. It just shows you a comparison. And for some of the optical purists out there, we have, or telescope makers, we have this standard of basically identifying how good is our lenses or the design using a Stroll factor. And diffraction limited, you've heard the term before, is everything better than 0.8 Stroll. So diffraction limited is about 0.8, where we're way higher than that. And it starts to drop off as you get above a degree field. So even with our telescope at f15, with the best glass on the market, even for the visual, over degree field, the performance starts to drop after 1 degree. And this is the color as well. So we're optimized for all of the color in the telescope, as you can see. And then as you get for photography, you're going to need to correct for the other outside colors that the eye do not see. So when you're designing for photographic or designing for visual, you have to take different criteria in order to correct for the two. This was the focus shift I was telling you about, the depth of focus. With our scope, we can basically focus plus or minus 1/4 millimeter. And we're still better than diffraction limited. And that's really, really nice, because basically you set the focus and you forget about it. There's no need for going in there and chasing down the image. Mind you, if you get somebody else to look through it, they're going to have to tune it for their own. So we got about 10 minutes left. Just quickly going through the making of the lenses. A little bit of money had to be spent in getting the gauges and getting tooled up in order to make make everything. The lenses, to give you an idea, the raw glass costs us $4,500 to the door. That's with taxes, shipping, customs, tips, whatever. $4,500 to the door. We still had to grind the lenses ourselves. Okay, we had to invest $3,500 in very accurate spherometers that would measure down to a 1/2 micron in Sagitta, because that would represent a change of radius by 1/2 millimeter. So you needed that accuracy. We had to measure the edge thickness, right here. We were allowed 1/2 thou around the edge. Can't have any wedging around the lens. The center thicknesses had to be measured as well. And then everything tested up against an optical flat of known quality and tested in an optical tunnel. And so it took about a year to make the lenses. And we spent 6 months actually making dummy lenses first, just to get a good feel for how everything would work. You had to test our tooling out, validate the accuracies and everything else. You didn't want to do that on the real stuff. So we actually made the lenses out of dummy glass first. And then after we were very confident with how everything worked, and we tackled the real stuff. After lenses were done, we had to coat the lenses, of course. And this is my optical chamber. I've done many of your mirrors over the years since '95. I actually did a load back in July, which I was happy to do for you. Saves a lot of shipping. I actually came down, picked up a load, then came back a month later to drop them off to everybody. This is my coating lab here. And so I didn't have to coat all the lenses, just R1 and R6, which is the first curve and the last curve. And what I want to do is just a very quick demonstration here to show you what that oil does in the lenses. If I can have the lights up. This is the hardest job of the whole project was oiling these lenses. You got no nerves left after this. Because they just slip around like, they take off after you. So what the lenses do, they basically eliminate internal reflections between the glasses, and they also eliminate any surface irregularities. So basically, you don't even have to figure the internal surfaces at all. You can just, right off the machine, you can oil them. They don't have to be tested or nothing. The only surfaces that have to be figured are R1 and R6. Now I'm going to demonstrate why we oil the lenses. Here I have a beaker. I'm going to place it inside of a measuring cup. And of course, everyone can see the measuring cup, or the beaker inside the measuring cup. So watch what happens when I fill it full of oil. Just canola. But we don't use canola in the real. The actual oil in the telescope is worth $500 a liter. It's a silicone-based oil that's used, perfectly transparent. It's got no color to it. There it is. So it might be hard for you folks to see what's happening from down there, but the beaker has virtually disappeared in the measuring cup. All you can maybe see are maybe the writings.
Can you turn the handle more the other way?
You can't see the outline of the beaker. So it just gives you an idea of how great the oil works. When you look down the tube of this telescope, you don't see nothing. It's basically a black hole. The glass virtually disappears when you oil the lenses. And then by coating, of course, the front element and the back element really improves things as well. Okay, we're done with that, so I'll just quickly go through the rest of the slides here. And afterwards, you can come up and take a look. So the lenses were done after about a year, so now we started to now go, we had to get the machining done for the lens cell and everything. We bought the focuser as an astrophysics focuser, a 4-inch focuser, $1,300 for that. And of course we had to make baffles for the tube assembly. This is a floating cell so that the lenses actually are collimatable within the cell. And this is what happens when you team up a spiral staircase maker with a locomotive machinist. Both of these guys are telescope makers as well. Of course, Dennis is my partner with this project. Moshe Put is also from Sudbury, but now has a machine shop in Burlington, and he builds these locomotive trains right from scratch for amusement parks in China and North America and such. So by teaming these two guys up together, we had to build a mount. And here's it looks like a German equatorial, but it isn't. It's an altazimuth mount, because we wanted the eyepiece to always remain in the same upright position whenever we move to different objects. But we needed a very sturdy tripod made out of 2-inch red oak, 7 feet high, with an eyepiece tray. And that's the finished scope there. Anybody guess how heavy that telescope weighs?
24 tons.
382 pounds.
Pretty close, 450 pounds. Yeah, each leg weighs about 35 pounds on the tripod. The tube assembly weighs about 60. And of course, the equatorial, like the altazimuth head, that's where all the weight is there. It's all solid steel. And this thing moves like butter, and it's just amazing. The telescope's supposed to support the observer, not vice versa. You can actually lean on this thing and focus it. And of course, first light was very impressive. And I can spend a lot of time talking about what we saw, but what I want to really point out what we saw. This is M35. What you see in an instrument like this visually, you see all the colors of the stars. And virtually all colors of the stars you can see now with a visual instrument optimized like this. You can see all different hues of green. For example, everyone likes double cluster, right? It's a famous object that we all look at it. Well, there's a gloop. One of the clusters, 869, NGC 869. If you look at those stars in that little loop, they all have different colors to them. You don't see that in a reflector. You'll only see that in a high-performance visual refractor. That's optimized for true color correction. And when we looked at M35, it'll look like this. We can see color everywhere. And that's because of the correction, like I was telling you about. Aluminum, unfortunately, gray tones everything down. It actually puts a gray tone filter in front of your. When I give my coatings talk, I do demonstrations. I can show you if you have a silvered mirror or aluminum mirror, you put tissue paper on top of it under bright lights. The aluminum mirror turns basically gray blue, and the silver mirror turns white, just to indicate. So I just imagine like having a 15% or 20% gray filter put in front of all of your colors that you're looking at. You're basically suppressing all of the colors. So with this telescope, remember I was saying that we got to get all that light, all that information down the tube? Well, we did that. We achieved that with this telescope. Unfortunately, it was a great project knowledge-wise and experience-wise. The only problem with this whole project was the cost. It was very, very expensive to build, including the tooling and everything. We spent almost $15,000 building this telescope. So it's kind of unfortunate that to have an instrument like this, you got to pay that much money. And but we wanted a visual instrument that would show this information. So we have done it. But now we got our hopes for a 9-inch. And guess how much the glass is going to cost for that? Just $8,000 or $9,000 for one element, just for the raw glass. Yeah, and it would take 6 months to grow it. It's a crystal. It's a man-made crystal, calcium fluoride, and they can make it in Japan at O'Hara, but they have to make it into a mold. They have to grow it, so it takes 6 months to make. So that's something that we're looking at within the next 5 years. So, but I'm going to try to, as much as I can, I'll bring this down. I'll bring this instrument down to one of your star parties or near the observatory. Yeah, because like I said, I'll be coming down this area a lot more often now. So anyway, I know we're over time. We'll leave it like that, and feel free to come up and talk, and I can share my knowledge with anybody who wants to hear more about the project and what have you. And I want to come down again and give a talk on coatings.
Excellent.
Okay, thank you.
Well, thank you so much. That was amazing. 9-inch. I'd like to see that. All right. Sorry for running over. I did definitely want to give Alan a chance to run through that excellent piece of work there, and I'd look forward to you bringing that down. I will. Estelle, I won't talk about this because I already signed out this book. So, but Estelle is around. So, if you want to sign anything else out from the library, please talk to Estelle. Post-meeting entertainment, as per usual. Art and Ann Fraser are out in front there if you want a coffee and conversation, or you're looking for your art or your RASC membership info or cards, in fact. And Stephen is obviously around, you can talk to him for magazine renewals. Rest of the museum is closed. Snacks and dinners at Kelsey as usually. We had, how many, what number is that? Triple X? 108. I meant Roman numerals. What was it? 3 tens in a row? Oh, come on, you guys. Anyway, 108 folks. So thank you all for coming out. Thanks to our contributors there. Sorry again that we ran over. I'm going to blame that on Chris. He just jammed way too many slides in the presentation. And he's not here to defend himself, so I feel good about that. And let's see what else. Last one. Next meeting, October the 12th. Okay, so hope to see you here. Hope you have a great month. Remember, September, one of the best months for observing. Go out there and have a look. Monday and Tuesday are supposed to be wonderful. No moon. Enjoy. We'll see you in a month. Oh, you have a question? What? Calendars, are the calendars available? Coming? They're coming. Sorry. Thank you again. We'll see you next month.